Okay, so moving on, we are looking now at what we call declining balance depreciation. So we've talked about depreciation a little bit in previous topics, but like with a lot of things on this channel, I'm going to try to go through this quite slowly. First of all, doing it the long way so we can kind of get an understanding of what's going on before I then give you the formula at the end. So this word depreciation, a good way I like to think about it, kind of sounds like the word depressed. So when you are depressed, you feel down. So when we're looking at money, we are going to assume the money here is going down instead of appreciating, going up. Now, this is all to do with goods or any asset which loses value over time. Now, a really good example of this is cars. So let's say a car is bought at $20,000. We're going to pick a really nice number. So this particular car, let's say we bought it for $20,000, and typically cars are a very good culprit of this. They lose money over time. They depreciate in value. Their value goes down. Now let's say that this particular car, to get another nice round number, let's say this depreciates at 10% per year, each year. So it's going to lose money. Now, we're going to do this the long way and see if we can find a pattern. So this is going down at 10%. So I want to first find at the end of the first year what its new value is going to be. We're going to write here end of first year. We have 20,000 and we want to find 10% of it. So we want to times that by 10%. So this gives us 2,000. So this goes down by $2,000 after the first year. So the price, its value, actually, I'll write value instead of price. Its value is going to be 20,000 and it's gone down by $2,000. So we're going to minus this. So the new price here is going to be $18,000. This is the price at the end of the first year. Now, its price has gone down, so when the next year begins, this 18,000 is my value at the start of the second year. So at the end of the second year, it's also going to go down by another 10%. But what changes here is this price of $18,000 is decreasing by another 10%. So we're going to look at what happens now at the end of the second year. So we want to find 10% of this new starting price. And that gives us 1,800. So we're going to take my value is going to be 18,000 minus 1,800. So once I do that, you guys can pause, pop this into your calculators. But once I take 18,000 and I minus 1,800 from it, it's going to give us 16,200. Okay, now let's pause for a minute here and actually look at the mechanics of what's happened. So I've decreased each of these prices by 10%. Now, if we decrease a price by 10%, that's like finding 90% of that original price, of the 100%. So if we try to notice a pattern here, and we're going to keep seeing this, for example, at the start of the third year, we're going to have $16,200. So we're going to find 10% of that. So if you notice, at the end of each year, we're taking 10% of a lower and lower number. So if I wanted to get straight from the start to here, I would do 20,000 minus 2,000 minus 1,800. If you guys do that in your calculator, that's going to get you this value here. But we're trying to come up with a general formula by looking at this pattern, trying to find a general formula that we can use any starting value, any rate, and any number of time periods. So what we're going to do, we're going to look at what happened in the first year. We took, so at the end of the first year, we took 20,000 and we times it by 1 minus 10%. We took our whole, which is the 20,000. So think about when we expand things, if we're timesing it by this, we have our 20,000 as our initial thing, that's the 1, and then we minused from that 10% of 20,000. Hope that's okay so far. So basically what we did 20,000 times 1 minus the rate. Now some of you may be seeing a link between this and things we looked at earlier in the series, but I won't spoil it just yet. But in this case, this was 20,000 times 0.9 or times 90%. Hope we're okay with that. As we take away, when we decrease by 10%, that's like finding 90% of that price. So that's what we did here. This is our price at the end of the first year. 20,000 times 0.9. That is the same as writing my 18,000. But what we did at the end of the second year is we took this thing that I have highlighted in blue, 20,000 times 0.9, and what we did was we once again found 90% of that. We found 10% and then subtracted it from that. So we times this again by 1 minus r. Okay, now 1 minus r it's the same rate. The rate hasn't changed. So this is like doing 20,000 times 0.9. That's our thing at the end of the first year. And at the end of the second year, we decreased this again by 10%, by finding 90% of that. Now look at what we've actually done here. Sorry, let me clear this from the previous video. We've done 20,000 times 0.9 times 0.9 again. If we multiply two of the same numbers together, we can just write this as 20,000 times 0.9 to the power of 2. So for example, at the end of the second year, we had 20,000 times 0.9 squared. If you put that into your calculator, you will get this same price in green that we found earlier. The reason why we do this is that we'll notice a whole bunch of other patterns with other things, is that every single time we're decreasing by the same amount. But just like compound interest, where we're doing interest on interest, here we're finding the depreciation of the already depreciated value. That's why we get the same thing happening. Now, let's formalize this into a formula. So, we're going to introduce something called the salvage price, which we give as S. This is the value it is at the end of this time. So if you have a salvage value, you're like, oh, how much can I salvage for this? How much money can I get for this thing that's depreciated? That's going to equal to the initial amount, V naught, they call it. You'll see this in your textbooks. This just means the value V of the item when n equals 0, when your number of years, for example, is 0. It's basically your starting price. This guy, V naught, is our 20,000 from the question. And the next part of this formula is your 1 minus R. This thing here is like if we, remember we wrote 90% or 0.9 as 1 minus 10%, 0.1. So your R here is the rate that it drops. And we had this 2 here because we did this after 2 years. This is to the power of the number of time periods that have gone by. In this case, the amount of years that have gone by. So we've basically, through this long and probably arduous task, we have come up with a universal formula for calculating depreciation or salvage values, where our S, actually let's do it like this, where our S here is the salvage value, how much we can sell it for, how much money can we salvage. Our V naught is the initial price, initial value, when the number of periods is 0. So right at the start, 0 years have passed, right? The R is the rate of depreciation. And your N is the number of years in this case, or the number of time periods. So if you look at this formula, sure, some of the letters are different, but is it not just the same principle as the future value stuff we were looking at with compound interest? Future value is the present value, the initial amount, times 1 plus R to the power of n. It is basically the same thing. The only difference is my negative and positive here. With depreciation, our price is going down. With our compound interest, the price is going up. The interest is going up. So hopefully this gave you at least a bit of an appreciation for the fact that we didn't just kind of pull this formula S equals V naught times 1 minus R to the power of n. We didn't just pull it out of nowhere. We got it by looking at how much something goes down every year. And we're looking at a percentage discount of the new amount every single time. And this basically just simplifies into what we saw here. I can just find that value after as many years as I want by just continually timesing the discounted amount by our 0.9, for example. This is the formula here, and obviously when we do the practice questions in the next video, we're not going to go through this in the very, very long way. The point of coming up with this formula is that now we have something that we can just plug in all of the important bits into. To find our salvage value, we take our initial value, times it by 1 minus the rate of depreciation, all to the power of n. We'll work through this a lot more in the next video. But thank you so much for joining me, and I'll see you next time.